In this video, we will be doing a quick how-to getting started with Connected Components Workbench when coming from some other PLC software. First thing I want to cover is importing a program. Now, for this class, I've been providing a template file for you. Instead of opening that file, we actually have to import it. So, about the same process as creating a new one, but instead of doing File New, we're just going to do File Import Project. All right. Navigate to wherever your file is. Go ahead and select the desired one. In this case, I'm going to use the copy. I'll explain that in a minute. Go ahead and hit open, and it will import that file from you. Now, the reason I want to use that copy file, not my other one, is because I didn't want to delete my other one. And anytime you import a file, it actually basically deletes the file that you were importing from. So you might want to be a little bit careful about that. It's a very simple process to import a file, but just, it's got its little funkinesses that you got to learn to deal with. So I need to be careful not to delete this file so you guys still have access to it. So importing, easy peasy overall. It comes in with whatever program you have, which in this case I have a timer and a counter testing, and it has all my global variables in it as well. So something to be aware of. Next, if you are going to do a new file, so we can go ahead and do that right now. You can call mine Project 5. That is fine. We'll go ahead and create. And notice it pops up right away saying, hey, you want to add a controller, device, motor controller, whatever to this right off the bat, which is kind of nice because, well, why else would you be coming to the software if you're creating a new file other than to put something into it? So for this purpose, for our class, we are going to be using the Micro 850. And we're going to be using the SIM, so the 2080 LC50-48 QWB-SIM. That's the one that stands out because it has -SIM at the end. So overall, very easy. Now, first you do have to select this PLC, all right, and then we can. I think you could actually at this point add another one, but we're only allowed one controller. So, but we already have it. As you notice, we've selected it. It's up here. It's kind of like uploading files to D2L or MyATLab or something like that, where first you have to add the file to it, and then you have to upload it. Same idea. First we have to add the PLC to the selection process, and then we can finally add it to our project. Now, once we're in here, you'll notice that it does have a whole bunch of global variables right off the bat. All of these that are _IO are the hardware inputs and outputs that are on the PLC. So if I go ahead and open up my simulator, here you can see the hardware IO. So we have _IO _EM _DI 00 through 27 for inputs, and we have 00 through 19 for outputs. If you click on these, you'll notice that the lights over here represent on the PLC saying, hey, this input's true right now. So we can very easily simulate actual inputs becoming true. We would see these outputs becoming true if we were online and whatnot, and we actually had code that would turn them on. And you would also see them light up here just like you see your inputs light up. So that is a nice little function there. Now, to add a program to this, all you're going to do is you're going to right-click on Programs, you're going to say Add, and you're going to pick your desired program type. So far, we've only talked about ladder diagrams. Later this semester, if we have time, we will get into the function block and the structured text options. But for right now, we're sticking with ladder diagram. You will notice as soon as you click that, you do get a local variables for that program, which starts out completely blank. Remember, local variables are only available within that program. So if you have multiple programs, local variables from program 1 are not accessible via program 2. So program 2 can't talk to local variables for program 1 and vice versa. So that is something to be aware of. So it's kind of safest to put them in global variables, but if space is an issue, and really overall, you should be using local variables over global. But sometimes you've got to use the globals. Like with factory I/O, we have to create global variables for it to access. We can't use local variables. So I talked about that in my other video. Now, there is an option in Connected Components Workbench, which is awesome for a quick declaration of variables. So if you right-click in, and it doesn't matter if you're in local variables or global variables, but if you right-click in here, there is a quick declaration option, which allows you to say numbering from a number to a number, And you'll notice if I put like 15 here, it goes I00 ... 15. All right. Or if I put 115 here, it now says 000. All right. If you want to have triple zeros no matter what, even though you're only counting 15, you can do digits and 0. And you notice that also, it basically only gives you the required number, or you can have a whole bunch of digits there. There we go. So how many digits do you want? So you would just type in, I want 3 digits or whatever. So it will give you that option to put how many zeros you want in front of things. But having 1 there keeps it from having excess zeros, which is both good and bad depending on your situation. So I really do like having 2 digits when you have 2-digit numbers because it keeps them in alphabetical order. So it goes 01, 02, 03 instead of whatever your prefix is. So like, input 1 and then input 10, input 11, input 12, input 2. I'm like, it's really annoying, but just something to be aware of. Prefix will put the I right in front of it, so you could call this inputs if you wanted. And then you can also put a suffix on the end, and you could call it like limit. Alright. So you can have stuff before the numbers, you can have stuff after the numbers. We do have the option for changing the data type here, so if you need to do ints or reals or words or whatever the option is. Alright. You also have directions. If this is going to be a straight up variable, it's going to be an output type or an input type. Alright. So overall, keeping them as variables will be probably your best bet. But if you have a need for the other ones, you can do that, which is very nice. And we just hit OK, you'll see that, bam, creates all those at once for us. So it's a very quick process for our purposes. When you're dealing with factory I/O, it might be a better purpose for you to say 1 digit for my numbers here. So bool _ in _ number, and have it just do 1 digit. That way it directly syncs up with what is in factory I/O already, instead of having to come back and modify all your single digit numbers because factory I/O doesn't put a 0 in front. So something to think about. Next, let's go ahead and talk about timers. Now, we use timers in Siemens. We've used timers in RS Logix 5000. And of course, this one is a little bit different. I have found that Connected Components Workbench is a little bit more Siemens-like than RS Logix 5000-like. But it is an Allen Bradley software, which I find to be kind of an odd thing. But that's okay. First, with timers. Alright, if we go to the timer counter tab, we do have time on, we do have time off, we do have an on-off delay timer, and we have a pulse timer, alright, and a retentive timer, alright. So, overall, the 3 that we've dealt with before are the retentive, the off delay, and the on delay. We're not going to get into the other 2 for this purpose, alright. Now, whenever you put a timer in, on delay is the one you're going to use the most, you'll notice that it goes to the left-hand side, which means as far as the software is concerned, this is qualified as an input, not an output. That is one of the places this differentiates itself from RS Logix 5000. As far as RS Logix 5000 is concerned, this would be an output. It puts it over on the right-hand side of the screen. Siemens qualifies timers and counters as inputs, so again, kind of more Siemens-esque here. Alright. Now, it's really nice if you just put your mouse on a function block or a program block, whatever you want to call these. It does tell you kind of what's going on with that block. So it tells us this is a ton timer, and it's named ton 1. It does say that is an on-delay timer, which is good. It is an on-delay timer. It tells us inner inputs, which is good, which we have input boolean, so that's just a normal logic. And we have PT, which is our preset time. And notice that it's the variable type time. Alright, we haven't really dealt with time variable types in this class yet. In RS Logix 5000, it's in milliseconds. So you'd be like, I want to count for 6 seconds. You would have to enter 6,000 in. Again, in Siemens, you could actually say 6 milliseconds or 6 seconds or 6 hours. So you just put the prefix, the postfix, suffix after it saying milliseconds, hours, days, whatever that option is. Now, I did bring up the help for this, which I found is very helpful. So I brought up the help just by doing help, view help. And then I just searched for time data type because I wanted to know more about it. So here it does tell you that the timer max value cannot exceed 49 days, 17 hours, 2 minutes, 47 seconds, and 294 milliseconds. And it cannot be negative, which is also important. And the reason it can count to that is because it is a 32-bit word. All right, so so little expression, we can go to 1,193 hours, 2 minutes, 47 seconds, 294 milliseconds. So other than this breaking out the hours to days, it's exactly the same. Here are all the suffixes that you can use. So you can do days, hours, minutes, seconds, or milliseconds. So if you just put one of those single ones. And notice here it does say it must begin with T number. All right. So you have to give it that T number. And again, Siemens, we actually had to do something just like this. It was smart enough to know that if you typed in 5S, it was 5 seconds, and it would automatically add the T number to it. However, Connected Components Workbench, you need to put that in for it. All right, it's not good enough to figure that out by itself. So, something to think about. There is a any to time conversion, so you can convert, so if you have, say, okay, I want to have an integer that I'm modifying somewhere else, you can then convert that to time. Or if you want to be able to enter things on a control panel or HMI or things like that, you can have a conversion that will take that into whatever purpose it is. So that is a very useful object for you. It has to have T-pound or time pound in front of it. So what we can type in here is you could just do T-pound, and I could say 5 seconds, and it would be happy. You could also go to your local variables, create a timer, or a time data type variable that you could put in there. So we're going to call this one desired timer time. Make sure that you make this the time data type, and then you can also set an initial value or a project value. So here I could put that time pound, we're going to go with 10 seconds this time, time pound 10 seconds. And then if I go back to my program, I can go ahead and type in desired timer time, and that is the equivalent of manually typing time in there. But it does allow you to change it after the fact with either commands or things along those lines. So it's a very useful object there to make a timer, or to create a variable for that. I find it nice to always have variables when you can, but just because you can have a variable doesn't mean you should have one. So it's definitely one of those little give and take situations, but I like dealing with variables rather than going through my possibly few hundred lines of code to find my timers to change things. So I would suggest creating a variable of the timer type for your timers and setting a project value for it. If you want to store something your elapsed time as something, you can put that variable in here, and it would store that just like in again, Siemens software. It has that option there. Now, the other thing that is Siemens-esque about this is this queue is not true until the timer has counted. So we can go ahead, put an input here. We're just going to go ahead and grab input 0. Let me go ahead and download this to the PLC. I'm going to have to give it a connection path because I have not downloaded anything to this PLC yet. And we're having, oh, I don't have it running. That's why it's mad at me. Alright, now that I have that running, let's go ahead and try this again. Go ahead and download that to our PLC. And once we're up and running, we'll be able to see that we'll be able to see that when I press the button, the timer will start counting, and after 5 seconds, that queue would output and be true, and you could control an output or whatever with that. So, it is very, very Siemens-esque, and the counters work the same way. So, once I go ahead and bring up this again, and I make 0 true, you'll see we start counting. And after the 5 seconds elapse, you'll see this blue line will become red saying, hey, the output is true. So you could put your outputs on there just like you could in Siemens. Still not my favorite thing in the world, just from coming from Alan Bradley being where I started, that I don't like using that. But if you like using it, by all means you can do that, and it will work just fine. You still can reference that. Now, you will notice that when I come in here, it is not listed as an option. Alright, it is not under global variables, it's not under local variables, it's not under system variables, it's not under I/O, it's not under defined words. Alright, it is basically nowhere to be found. Now, that doesn't mean that you can't access it, all right? And I've tried changing the Boolean type up here to a word. I've tried, let's go with ton1, ton1. All right, see, if I put ton1 in there, nothing pops up. If I put ton here, all right, nothing pops up. All right, so it's basically nowhere to be found. Now, you're smart enough, you've gone through enough of my classes to know that the output for a timer is the name of the timer, which does pop up if you start typing it in over here, dot, there we go, and we have Q. All right, so you can still use that if you want to. It's just a bit more hidden than it normally is. So let's go ahead and give us an output on this bad boy. Go ahead and hit OK. Let's re-download our code and give it a second. Alright, now that we got it downloaded, if I go ahead and turn input 0 on, we'll see that it's going to count up through 5 seconds. And now the output turns on, and you can see how the output is referenced here. So you can still do that. It's a bit of a pain to actually get that to show up there because you have to know what you're doing, but you guys should all know well enough how to do that. So, alright, the next topic is counters. Alright, let's go ahead and delete all of this. We can leave that there. Alright, so under counters, we have a countdown counter, we have a count up counter, and again, just like Siemens, we have a count up down counter. So we can just go ahead and throw that bad boy in there. Notice we do have a QU, which is the count up is complete. We have a QD as our count down is complete. So QU is true whenever we hit our preset value. QD is true as, I believe, whenever we hit 0, or, yeah, whenever we hit 0. So just something to think about. And again, we have QD here as well. Now, I do not know a way of putting multiple options. Let's see if we can do that. There we go. Nope. Alright, you can't do multiple options in QD like we could in Siemens. You know how in Siemens you'd be like, branch down, and then you would just drag this over to there, or, you know, something along those lines. You can't do that here. So you have to stick with what we got. But we can go ahead, let me go ahead and put digital input 1 on the countdown. Let's go ahead and put our PV. Now what PV is it looking for? Again, if we hover our mouse over it, it tells us PV is a dint. Alright. If we look at the dints, we will see that it is a value from negative 21474836648 to positive 21474836647. So, very, very large area there. Alright, constant value. Yeah, so 32-bit value here as well. So we can go rather freaking large. So, you know, probably you're only ever going to need that, hopefully. If you do, you could always cascade them. By the way, you can cascade timers just like we did in Siemens or earlier in the semester here. So that process still works. Anyway, so this is a integer though, basically. It is a double int. So that means it is a whole number. We can't use decimals here. Why would you want to count in decimals? I don't know, but you can't do it. So you'd have to use a conversion if you're coming from a decimal number. But anyway, so we can just type in like 6 and be done. All right. And then let's go ahead for good purpose here and throw in a reset. There we go. Let's go ahead and give this another rung just to be and give us a nice output. So we can say normally open, normally closed. Ooh, come on. Let's type here CTU D1 dot, and we're going to say when we've hit our count up or our QU value. Alright, and we're going to just go ahead and give it digital output 0 for our output. Let's go ahead and download that. And we should be downloaded, and there is our code running. So we can go ahead and click this on a whole bunch of times. You'll see our counted value will go up. Simulation is a little slow. We're at 5, and now we're at 6, and we should see our output come on. If I click 01, you'll see that we should go down, and I click 02 and we reset. So it works just like Siemens in the long run. A little bit tweaking since we can't have multiple on the countdown or the reset line or things like that. But again, you can get around that by, turn the net off, by doing something with like a whole bunch of inputs, you know, down here. Here we go. We could do a whole bunch of random there. Give us an output. Not the output I want. There we go. And you can actually make one while you're putting this in. We could call it the counter reset. Okay. There we go with the counter reset. And then you could put counter reset in here. So that way you have all those when they're true, the counter resets. So, nice little thing. Now, if we do go into our local variables, you will see that we do have this CTUD here, which does have all of those values in it. All right. Notice we have even this PCU and PCD, which is our previous count up value in our previous countdown. We do have those overflow and underflow, so if we somehow count over that max value or under that max negative value, that will pop up on you. So, and it even gives you comments, which is kind of nice, like the load command, CV equals PV when load is true. So our counted value equals our preset value. So anytime load goes true, it moves whatever preset is into counted. So kind of a nice little option there. Nice that it's giving you those comments. You can rename your counters in here if you have a good need for that, which you should do. Timers would show up in here too if they are in your program. So if we go back to our program for a minute and I just throw another timer in here, you'll see that will show up in here as well. Alright, and it gives you all of that other stuff. Even previous date or a rising edge. So it does give you a few more things. And if you need more information on that, go to your help window, bring it over, and search for ton. And it will tell you all the information you could ever want about that specific timer. They even have timer instruction configuration, data types, all sorts of other things in here. So really good information capable. And they actually are showing you a function block diagram one, a ladder diagram, and a structured text option. So also pretty nice at how they're doing that for us. So alright, I think that is a quick get you up to date on the slightly funky things for Connected Components Workbench compared to RS Logix 5000 and compared to the Siemens software. Have a nice day.